So this is our problem statement. So we have to perform static analysis to find the stresses. So this is the force 15,000 Newton at top of the connecting rod. The magnitude of load is 15,000. The constraint the lower region, that means you have to constrain this crankshaft connecting point here and perform fatigue analysis. It is important to find fatigue life of connecting rod as it is subjected to continuous cyclic loads. As the failure for this component is within the elastic region, we are going to perform fatigue analysis using SN approach. So we are using SN approach. I will show you how to change approach also in ANSYS. And then the output is the life. That means how many days or how many cycles this component will sustain for this load, and the damage, how much damage will happen to connecting rod due to this force. So let's go in. So this fatigue analysis comes under static structurer. We can do it in static structurer. So I will just drag it and leave it here. I will import a geometry here, connecting rod, and then I will go in mechanical. So this is our component. You can see we have to apply load 15,000 in negative y-axis at this location, and constraint is at this point. So firstly we will mesh this, generate mesh. Here you can see mesh is completed. Now I will insert the force. Insert force. We will apply the force at inner surfaces. Say apply. Then defined by, I will change it to component, and at y-axis I will define a force which is minus 15,000. Here you can see the arrow which shows the direction of force. Then I will apply a fixed support at here. Say apply. So then I will insert a deformation, total, and equivalent on my stress. And then firstly I will show you how the component will deform due to this force. This is the solver window. So the solution is complete. So here you can see how my component will deform due to this force. And the deformation is 0.0758. Maximum deformation is 0.078 mm, and stresses is 504 megapascal. Maximum stress. So now I want to check the life of the component. So how much days my component will sustain. So for that I will import a fatigue tool. So just right click on solution, insert, and here you can see the option called fatigue. I will select that. You can see the fatigue tool. I will import a fatigue tool. So here you can see the cyclic load. So what is this? I will show you here. At details of fatigue tool, here is called fatigue strain factor. I will set it to 1, fatigue strain factor. And in loading, the type, here you can see the fully reversed is selected. That means here you can see from from 1.5 to minus 1.5. It is varying. So it is varying between these two values. If I select it 0 based, then you can see it will varies from 0 to 1.5 only. If I set it to ratio, then you can see 1 to 1. That means it has considered the ratio of the load. So I will set it to the fully reversed. Fully reversed. So it will go in negative direction, then plus, negative, in plus. This is not also that this is not negative actually. So in displacement time, I will set it to the n time here. So in analysis type, here you can see the stress life is selected. Here you can change it to strain life also. As per my problem statement, it is defined as a stress life. So I will set it to the stress life. Then mean stress theory, I will change to Gerber. I hope you have covered this all the types of theories in some. It so in stress component, I will change it to signed on my stresses. And result type is stress. So here in life units, you can see the unit name is called cycle. So here you can see there are lots of options at seconds, at minutes, at hours. That means for how many days, for how many hours, how much minutes, seconds, my component will, or months, how my component will sustain for this force, this repetitive force. So if I want to check for how many days my component will sustain, so let's say I have set it to the days, and one cycle equals to. So you have to, if I set one cycle equals to 1 day, that means one cycle will complete within a 1 day. So I have set it to 1 day. How much cycles complete within 1 day? You have to set here. So I have set it to 1. So this is the inputs required in fatigue tool. Then I will right click on fatigue tool, say insert life, which is my output, and then the next is damage. Then I will solve. So the solution is ready now. So this is the life. So here you can see 1409 days. My component will sustain at this part. Here you can see. Then here crack is generated. Then after this days, the crack initiation will start. Sorry, we are using stress method. So no crack generation, it will fail. So I will show you the animation. Here you can see the maximum deformation, and also you can see the damage. So what is the 10 to 6 means? The 10 to 6 has an infinite life. So my minimum life is 1509 days. So this is all about today's session. We have seen how to perform fatigue analysis. Thank you for attending session number 25. In tomorrow's session, we will see the thermal analysis.